A very important database concept for businesses is known as the many-to-many relationship. In this section of Chapter 2, we're going to discover exactly what that means. Let's use a school example. This is Joan. Joan is a soccer mother of the J family. Her two active children are named Joey and Janet. Joan picks up her children from school each day. She is also authorized to get them from school if they become sick or injured. Since Joan is a parent, and she could have more than one child, we need to be able to handle her authorization to be the guardian for many children. So here's a common proposed solution. Look at this example. We decided to put the parent ID in the child table, pointing to the parent. Now, this allows us to answer such questions. Assuming the school is keeping track of the database using this design, which two children are allowed to be released to Joan? Let's look. Joan is parent ID 1001. So we scan the child table and we see two records with a parent ID of 1001. This tells us that Janet and Joey belong to Joan. So which children are allowed to go home with Sue? To find out, let's run a similar process. Sue is parent 1002. I see two instances in the child table, Kayla and Andy. Which children are allowed to go home with Sarah? It looks like Sarah has only one child, Robbie. So who is Kayla's parent? Well, that's easy. We see Kayla is 2003, her parent is 1002, and we look at the parent table, that answer is Sue. Well, that works great for a little while, but let's use this example. Joey gets sick and the school nurse calls home. Joan is out of town, so Joey's father, Ed, shows up to get him. The problem is there's only one parent ID listed in the child table, and it refers to Joan, not Ed. So this doesn't quite scale enough to handle both parents. You might be tempted to say, well, let's have a parent ID A and a parent ID B, and then look it up that way. All right. That works for a little while, but what do you do for a remarried family where a child now has 4 approved parents? Let's introduce the bridge table. The bridge table tells us that parent ID of 1001 has 2 children, of Janet and Joey. It also tells us that Joey has 2 parents. As we can see, 2002 for Joey maps twice to the parent-child table, showing a parent of 1001 and 1004, which is Joan and Ed. One parent can have many children, as well as one child can have many parents. Therefore, the parent to the child table is a many-to-many relationship. So repeating fields like parent 1, parent 2 is not the answer. It leaves you with wasted nulls and has a lot of limits on scalability. We introduce the bridge table. In this example, the parent and child tables are called LookUp Tables. The table in the middle is called a bridge table, and sometimes called a junction table or a mapping table. So, using this example, what's the name of Lisa's child? Well, looking in the DBO parent table, Lisa is 1001. How many times do I see 1001 listed in the parent-child table? Just once. And it looks like that's child 2002. The child's name is Nate. Who are Nate's parents? Well, 2002 is listed twice. 2002 maps over to 1001, which is Lisa, as we saw before. But towards the bottom of the table, we see that 2002 maps to parent ID 1005, which is the name Clive. Now, which child has only one parent listed? Well, let's go to the parent-child table, and let's look. 2001 looks like Billy is only listed once. Billy is a child of parent Clive. It looks like 2003 Tanya is also listed only once. Tanya belongs to 1004, which is Sally. So let's use a many-to-many example in the most common form it is used in business databases, the invoice example. Now, what we have here are products and invoices. A product can be ordered many times on many different invoices, and an invoice is kind of like those shopping carts when you go online. Those multiple items go on one invoice. So, an invoice can have many products in its cart, and a product can be ordered on many different invoices. Here's our bridge table. So what products were ordered on invoice number 5631? Well, if we look at 5631 in the invoice table, we see that is listed twice in the invoice detail table because this person ordered a toy car and a Furchie. How about the product GoDuck? How many times has that been ordered? Well, GoDuck is listed on invoice 5633 and 5634. Therefore, there were two invoices, one on July 15th and one on September 22nd. So this might be more of the database layout of the sales invoice mapping to the bridge table sales invoice detail, which will map over to the current products table. And the current products table can give you the details of the products we ordered. So let's look at sales invoice 1. Sales invoice 1, it looks like there were many things ordered on that invoice. Product 76, product 77, 78, 71, and 72. What are those products? Just look over in the current products table. And we see an Ocean Cruise 1 week East Coast, a Ocean Cruise 2 week, and so forth. So, the sales invoice can have many products, and a product can be ordered on multiple sales invoices. Lab 2.3, Skill Check 1. Write a query that shows all the invoices ordered by customer number 490. Show all fields from both tables, sales invoice and sales invoice detail. When you're done, your results should resemble the figure you see here. Skill Check 2. Write a query that combines sales invoice detail, and current products. Show the following fields: sales invoice customer ID, sales invoice invoice ID, sales invoice order date, sales invoice detail quantity, and from the current products table, product name and retail price. When you're done, your screen should resemble the figure you see here.